Well, thank you so much, and thank all of yous out there. Remember, it's only as good as your last car that you fix. That's all that is. Anyway, welcome everyone. Here's what we're going to cover. The first place to start when we're talking about diagnosing, we need a game plan. No team ever wins without a game plan. That is super important. Strategic-based diagnostics and diagnostic routines. Oh, I think you're still on, and I'm not in a big picture. Do we need to do anything with that?
You are good. Continue.
Okay, I'm in a little thing, as long as that it's okay with everyone else. PCM strategies will be covered. Enabling criteria, super important. Diagnostic exercises and case studies. Now, this is a short presentation. It's only about an hour or so. And we could go a little more. That'll be up to you. There's no such thing as a stupid question, only one you don't ask. Now, I don't know everything, but I do know a lot. And all this stuff came from my shop in my bays. You may have read my articles in Motor Age magazine or seen some stuff online. So again, I don't know everything, but I do know a lot. Here we go. First place to start is by interrogating the driver. Don't beat them up too much, but interrogate them. A good Q&A session may lead into an area that you wouldn't even think of looking at. So that is the important thing. Find out when it happens. Does it happen when they're making a turn, pulling a hill, coming to a stop? The next step is use the most important tools you have. Not that shiny pink toolbox that I don't even need to know about, but your brain, your eyes, your ears, your nose, your hands. That is the important stuff, right? You got to use them, engage all of your senses. After the preliminary look-see, make sure you check out the TSBs, look at everything, and see what you're going to do for your next step. TSBs can be helpful. Information on IATN, diag.net, Identifix, AllData, ProDemand, Autodata, MotorLogic, YouTube, and even Google could be super helpful. You need all the information source you could absolutely get when we're working on these complex machines. These machines are becoming super intense and electrified. You know, when you think back to July 20th, 1969, you know what that date was? It's when we landed on the moon, okay? If Neil Armstrong didn't know how to fly that space capsule, it's like flying a helicopter when I used to fly, and took the cyclic, he would have went to the dark side of the moon. It would have matched up with that Pink Floyd song there, okay? But lucky he knew how to do that. Now think of that computer power, and we'll go back with a GM car to 1980. 160 bits of information per second were in that computer. More than that landing capsule that landed us on the moon, believe it or not. Go to Air and Space Museum, check it out, and you'll see what I'm talking about. We get up to 8,192 bits of information right in 1995, right before OBD2. Then we go to 10,400 kilobytes of information on the first OBD2 systems, and now on CAN, Controller Area Network, 500 million bits plus of information. So think about that, how complex these things are and how much information there is out there. This is why we need to look at that. You need all the help you can get. When you're looking at a silver bullet solution, well, it may not be a silver bullet solution. Always test and not guess, that old sun saying. So remember, when looking at it, check the component out. Don't just put it in. You know, in this country, we become very dependent. I say codependent. Now, we're not talking about the political situation. It's a whole other nightmare. We are talking about code dependent. If you get a code for a mass airflow sensor, don't just throw a mass airflow sensor in it. Diagnose it. Test it. That's what we got to do to diagnose and fix today's vehicles. The game plan, part of it is going to NASTF, NASTF.org. The reason why you want to go there, if you change a computer out of a vehicle and put a new one in, you're going to need to program it, and you would have security issues. Do you have an LSID/VSP? That is a service professional license or a locksmith license. Therefore, when you put a new computer in a vehicle, you can program it because security is everything on today's vehicle. It'll cost you about $300 on NASTF to fill out the forms, get vetted so you can actually do these things. But you're going to need this if you're working on modern cars. You're also going to need it right here, auto auth. Auto auth, you may have heard that two guys hacked into a Jeep system and shut the Jeep down as it was running down the road or driving down the road. Okay? And when they did that, they were actually caught and prosecuted. The FBI was able to arrest them, but Chrysler winded up hiring them. And the reason they made this deal is, you know, all the smart engineers not only work for Chrysler, but for other companies, they didn't realize that someone could hack into the vehicle and shut it down. Now think about that on your major highway. You imagine vehicles shutting down and you got a big tractor trailer loaded with gas or liquid propane or some other nasty thing. We could have a huge disaster like that. So they have put gateway modules in, and starting in the year 2017, Chrysler prevented everyone from going in and taking their regular scan tool and going to all the modules and actually clearing a code or doing bidirectional control. But if you have any scan tool, whether it be Snap-on, OTC Bosch, Launch, Autel, Autoland Scientech, Top Don, Car, no, I can't think of car something or another. But any of those scan tools out there, you basically, if it can go online, you need to register the tool at Auto Auth. So you go to Auto Auth, costs you $75. You can get 6 of your technicians in your shop registered. They want to know all their information. This is something that's going to be helpful so you can get through the gateway module currently on Chrysler. Write this down, because Nissan and Infiniti are now doing that on their factory tool if you're an aftermarket user. They have not decided if they're going to go with Auto Auth or some other company. All the other car companies will be doing the same thing as Chrysler did. So that means you're going to need to get your tool vetted. Okay? Very, very important. Now moving on to game plan, well, you don't want to see stuff like this here. Look at this. This is nasty. If a car comes in your shop like this and you let it out, shame on you. That is VD, and we're not talking about some disease, we're talking about voltage drop. And that voltage drop can cause a major problem. So the next try starting your diagnostic procedure with testing from the basics up, finding out what's right and what's wrong, just like the big box scopes of yesteryear. Super important on that. The good thing about the old big box analyzers was they forced us to start at the battery, the start of the alternator, the mechanical condition, the emission gas readings, okay, not for an inspection test, but readings so you can see what the engine is doing, ignition, fuel, and scan data. So never ever let a vehicle go out like this. In fact, this one came back on a hook because this customer was wacky. He told us, do not clean his battery. Okay, well, he came back on the end of a hook. That was about 3 months later. Batteries are not the same thing. This is not your father's Oldsmobile, Pontiac, Plymouth, or Saturn. They're out of business. Your ass will be out of business. Okay? So remember that things are different. Battery coding or battery registration is not only for Euro cars. I've been doing it on Euro cars for years, okay? Probably 15 plus years. But now you got this on GM, Ford, Chryslers, and soon to be on every vehicle. So basically, registered and programming are 2 different procedures. If you're replacing a lead acid battery with an AGM, you're going to need to program it. If you're replacing the same battery in AGM with the same rating, then all you need to do is register the battery. And you can see here, you can register this battery here right on a Snap-on scan tool. But you can do it on many scan tools. Your favorite one that you like, your Autel, your Launch, whatever, you can do that. When you don't do that, a lot of people go, well, what do I need to do that for? Well, first of all, you better RTFI, read the frickin' information. Because if you don't do that, and out your way, you get a lot of rain. You may just have a procedure that you didn't perform and the guy's moonroof opens up or his windows go down and you have a torrential rain and his inside of his vehicle gets wet or her vehicle gets wet. They're not going to like you too much, are they? So always read the information, see what you need to do, register the battery, because if it thinks it still has the old battery in the vehicle, guess what? The charging rate's going to be different. Today's vehicle, as I said earlier, is a super duper computerized machine, and it needs things to be precise. Not, it's close enough. Those days are gone. You are a professional, so you want to do it the best you can do in the correct way. Testing AC voltage. Now, when we go to the battery, or behind the alternator, whether we're using a meter or a scope, AC voltage, the maximum amount should be 500 millivolts. Now, on a lot of European cars, we really don't want to see more than 200 millivolts. So some alternators are very difficult to get out. You can't get your arm all the way out there. Just like Medtronics or associated and Snap-on testers that go right to the battery, you can go right to the battery with your meter or with your scope and see if you have an issue. Let's take a look at, I'll blow it up for you. Oop, sure I will. I'll blow it up for you here. And let's take a look at this diode ripple. So here on my old Interro unit, well, the diode ripple is good. It's under 500 millivolts. Here on my e-scope, it's no good. It's over, okay? So if you see something like that, that diode that is no good, AC rides on DC, that can cause you a lot of problems in the system that you're working on. Now, another big thing that we deal with is parasitic draw. And when a vehicle comes into your shop with a parasitic draw, you need to know how to diagnose it. There are multiple ways that we will discuss. But some people don't realize when they disconnect the battery cable that they may have a relay that was sticking before, like on a Ford fuel pump relay is very, very common, right? And if you disconnected it, what happened to your parasitic draw? It went away. Now you're not going to find it, correct? So you would need to hook up a battery pack to maybe behind the alternator or a high voltage area. Some people like using the OBD2 connector. Remember, the OBD2 connector is roughly on a 4 to 6 amp fuse. So if you have something pulling a lot of current, well, that fuse may be blown and you may think you're powering the vehicle up, but when you disconnect the cable, you lost everything. Not a big fan of going into the cigarette lighter. Not a smart idea in my opinion. But here, if you look at my student's pants, the lights are on this vehicle. The tech has the light right on his pants. The negative battery post, the cable is off the post, and we're going to look at 2 different meters here to show you the original way of actually doing this, where we're in our amp meter, 10 amp jack. We have the red lead here. We're going through a 10 amp circuit breaker. And this is done intentionally here just to show you 2 meters. We already used a battery pack, so we didn't lose anything. Soon as we disconnected, and as soon as we disconnected the battery pack or turned it off, and now all our current is flowing through here, going up to the meter, coming down, and going through the system, okay? Now, we also put this amp clamp here because a lot of you own this, but this amp clamp has small jaws that can't go all around the cable wires. You need to get around every wire cable as possible. If not, like if you left this off and didn't get all the way around it, you're not going to get a reading. This is why we have it on here, just to show you how accurate the clamp could be. Write this down. I'd recommend what we use is an I-30S flue clamp, an I-30S. It'll set you back about $500, where this is only $100. But again, you're going to have to do some movement of disconnecting and putting a wire like that, and who wants to do that? So what are we reading up here? 14 amps, 210 milliamps. Why? Because each headlamp will roughly be about 5 to 7 amps. There's 2 of them, and each light bulb is about 8 to 900 milliamps. This vehicle had 2 park lights up front, 3 on each side and the back, so roughly we're in the 14 amp range. Now, if you go use your amp clamp, we go into the common and we go into the voltage jack. It's a conversion. Every 100 milliamps, where my little arrow is here, we zero the clamp near it before we put it on. Every 100 milliamps equals 1 amp. So our meter is reading 1.456. A lot of people don't know how to read that correctly. So when you got 1 volt, well, how many hundreds of millivolts in there? 10. So that right there is 10 amps. And then if you covered the 1, the 456 would be 456 millivolts, and that would equal 4.5 amps. Does that make sense? 4 amps, 560 milliamps. If this was a number 2 or a number 3, 2 would be 20 amps. That would be 24 amps. So it's just a way of looking at it. Now, obviously, there are easier ways. You can do things like I would suggest here. This one I caught on an alternator with my old Fleur, and it's black and white, but you see the bright part where my little green laser pointer is here? You see that? That is actually telling me the diodes are no good in that alternator. And if the diodes are no good in that alternator, that's my parasitic draw. Okay, that's one of the things you need to know. This here to the right is my newer Fleur unit, and this is very, very common. How many of you have had an issue with Honda or Acura vehicles? Battery goes dead. Number one problem is going to be the AC relay. We keep at least 4 of these things in stock, and this is a common problem. Now, a lot of times, don't go nutty and start changing a bunch of stuff yet. You're going to need a new relay, okay? If the relay you put in that's brand new has a problem where it's staying on, because usually it's just a relay issue, then what I would say to you is you probably have a bad clutch. The clutch is overheating the relay. Now, we've only had a few of those that were bad, mostly just weak relays. Put a new one in, problem solved. Again, a thermal imager can show you a lot of neat stuff. Let's go on a rough running Dodge. We got some of the basics out of the way. A 2016 Dodge Caravan with a 3.6 with 16,346 miles. Came in with a complaint of rough running and an illuminated mill. After our initial diagnosis, we connected our scan tool and obtained the following results. A P219A air-fuel ratio cylinder imbalance. And you go, oh, I never seen that one. Well, it's a manufacturer code. It's probably why you didn't come across it that much. This was not the DTC we expected, since the engine was running rough due to what seemed to be a severe misfire. Looking up the DTC and Pro Demand provided us the following information on what can cause the code. There's several different reasons. Intake manifold leak, fuel injector, variable cam lift failure, camshaft valve train problem, ignition system, or a mechanical issue on a specific cylinder. Well, that's just about everything, isn't it? So you got to check, right? And once you have your diagnostic game plan, battery, starter, alternator, check the mechanical condition out, right? Then we would move on. We had done that on this, and scan tool data displayed injector pulse width of cylinder 1 at 2,400 microseconds. 1,000 microseconds make 1 millisecond. 1,000 milliseconds make 1 second. While all the other cylinders were at 1,900 to 2,000 microseconds. We connected an amp clamp on the injector number 1 that displayed only 650 milliamps on the scope. So let's blow that up, show you the scope pattern. And one of the things I want to ask you right now, do you think 650 milliamps is enough for a regular injector? And the answer would be no. Okay? That's usually when the pintle bump starts to open up. Most saturated drive or conventional injectors like this Caravan uses are roughly about 900 milliamps to about 1.2 amps, which is 1,200 milliamps. So here, you can see we're at 0. We go up. There's our pintle bump. And here we're about 50 some odd 100. And here we're at 65. So we're only 650 milliamps. Not enough to give us enough fuel in that cylinder. So next we checked cylinder number 3 current. That was easy to obtain a reading from. It displayed the 950 milliamps. This is the normal, right? I decided to take out the OTC injector tester that allows us for easy connection to the fuel injectors so we can do an ohm and volt coil test. The results of the ohm test on cylinder number 1 was 32 ohms of resistance, while the spec is only 12 to 15. So you're going to see a little video in a second, but let's blow this up and take a look at the amperage. So when you look at it, we're roughly pinto bump at about 600 or so milliamps right there. Our maximum, we're about 95, 98, okay? So just under 1 amp. Now that's what a good injector should look like. Now this made sense. Since high resistance equals low amperage, the injector could not pull the proper current to open the pinto. Remember, we're going to have 45, 50, 60 pounds, whatever the system may call for of pressure. It has to go like this and open up and let that fuel through, right? So to confirm that it was not a computer driver problem, because remember, you could have a driver problem. You could have VD. You could have a bad ground from the computer. You could have bad power. We checked both of those. Those were good. But to confirm it, we wanted to make sure we load the circuit with the same thing. We connected the wires from number 1 cylinder to number 3 injector and vice versa, and found that the driver was good. The test confirmed our resistance finding that there was an internal resistance issue since the terminal ends were clean and both injector drivers were able to produce the proper amperage on a good injector. We looked at the emission warranty and recommended the owner bring the vehicle into the dealer for free. We actually made the call for this customer. It was an older lady. The dealer warranted the injector, and the Caravan was now running as designed and back on the road with one happy customer that is going to like us. So we got our diagnostic fee, but we got that fixed for her for free rather than us charging her. And we proved it out. So take a look at this video. This is the OTC tester before we get started here. This is our meter. We got it on ohms. We zeroed it out. Remember, 12 to 15 is normal. Watch the video. All right, so we have a car here with a code. What was the DTC, Bill?
P219A. It's a fuel imbalance on bank 1.
So fuel imbalance. So one of the things we tracked it down to is a problem injector. Now we're on a good injector back here. We're going through this box with our lead and we see we got 13.3 ohms. We're now going to switch over to the cylinder that we believe is the problem, and let's check our ohm resistance out here. And can you see that? We got 31.2 ohms. You may go, well, what's the difference? Yes. High resistance like this is going to give us actually low amperage. And the pintle has to open up about 600-700 milliamps. The current on this is going to be different. We have a bad injector that is causing the problem. We'll attach a couple of pictures that Bill actually did current ramping this injector. So that's how to check an injector. We're going to prove one other test here called the coil test. We know the resistance of the injector is, so Bill, go ahead, press that button and let's watch what that voltage reading is. This is the good injector. So we got 6.6 volts, 600 and something millivolts. Okay, and that's on the good injector. We're going to switch it to the bad injector, and of course we're going to start it up before we do this cylinder because we don't want to hydrostatically lock anything. So you hear the motor start up, we'll clear it out. We're good. And now we're ready to go on this cylinder. Press that button, Bill. Look at that. We got 11.43 volts. 11 volts, 200 something, 10 volts on it, staying on. Look how much longer this thing stood on doing it. So that proves the coil test has failed and it got a bad injector. So we checked that two ways. So here's the current ramping.
Yeah, it's going up to 950. This is a good
950.
cylinder.
Oh, yeah, that's a good one. And the pintle bump, roughly
Yeah,
over
around
there,
seven.
about 60, 70%.
Yeah.
Okay, and where's the bad one now? Look at the bad one. Pronounced pintle bump. And what's our maximum amperage?
Like 650 milliamps.
650 milliamps. So lower current, which means it can't get all the fuel in the cylinder, there's where we get the imbalance. Great job. Okay, so you may be wondering on this caravan here, how in the world did you find to go to the injector? So what Bill did, he used the launch scan tool, didn't go into the factory tool. And important thing is crank is synced. But go ahead, Bill, explain. I think you guys could see the numbers there.
Yeah, so cylinder 1 is at 2400, and that's microseconds they're counting it in. And all the others are around 19 to 2000, so it's a bit higher. So it was trying to add fuel to that cylinder, and that's what was throwing the imbalance code.
So the injector on time was being commanded for the
Wider.
computer to stay on longer, but because of that low amperage we looked at before, he couldn't deliver it.
Yep.
Okay, so does everyone understand what we did there? We came in with a code. We checked things mechanically real quick by doing a relative compression test, which we didn't show you here. And when we came up with that code, we did a resistance test that we showed you. We did, and that's only after looking at the last part we showed you. We looked at the scan tool to see there was an issue. That's what led us to do resistance, coil test, and actually current ramp the injector. The new injector fixed that car. Moving on. Exhaust back pressure. You can't get 5 pounds of dew out of a 1 pound bag. A lot of your testers that you have, the information that comes with it is absolutely wrong. A clogged catalytic converter can mimic a major engine or tranny problem. Good exhaust back pressure at idle should be 0. Anything more than a half a pound, anything more than that half a pound at idle is no good, or a pound and a half at 2500. You should not have anything like that. A good one is going to be down here. You see this bad one? We're about 4 psi. About 4 psi there. Now, another way, if you want to go into splitting the hairs and actually seeing if something is really bad, and maybe, you know, the air fuel or oxygen sensor looks like the bung is going to break or the sensor is going to break, take out a spark plug. Put in a pressure transducer like I did here. And what you're looking at is on this compression waveform, you're going to see where this red line is. It is going up and up as the exhaust pocket right here, exhaust intake. You can see the steep rise, how we are rising up here to where it is proving to us that it actually has too much exhaust back pressure. Now, an easy way of doing that is, no, this is not Bart Simpson saying hello to you. Hey, how you doing? Nope, that's not going on there. What you have here is basically frequency. Frequency, the amount of time something happened in a second. And this is from the mass airflow sensor. No, you don't need the E-scan to do it. E-scan shows you in red where you should be. Yellow is actual. You just need to go to calculated load PID on your generic scan tool. Even a little launch code reader could do it. You don't need an expensive tool. Pick 1 to 2 PIDs. You may want to pick RPM or throttle or APP, and calculated load, about 1 car length, give it a little whoop. And if you don't get up to about 90% of calculated load, you got an issue. If you see Bart Simpson's hairdo, that equals back pressure, okay? Then I would go and do those 2 tests I just showed you. I did it in reverse for you to keep you going, okay? Oil. Oil issues are a biggie. Again, things have changed over the years. You need the right oil in a car. We had this CRV come in with a bucking complaint, had a P1259, that is a Honda DTC. The son-in-law changed the oil and put 1030 in rather than 520. Okay, what a rocket scientist, right? The vehicle ran perfect when it was cold, but when it got hot, the VTEC system could not actually allow the timing to change right. And the engine would buck like this. It was nasty. The fix was changing the oil in the filter, put in the 520. Now, a lot of Hondas use 020, but, put the 520 oil in. This was a 520 car. We had this 2013 Porsche come in, and here's what it should look like. Unfortunately, the other shop that did the oil change had no clue. It's a stickless car. We also have the Porsche factory scan tool, but no need really for that if you know how to get that display up. When I drove the vehicle in, it actually had this in red and came up with this: oil level above maximum, consult workshop manual. When I see a sticker from another shop, we're all professionals. I gave the shop a call. The lady already gave me an earful how she went to this other shop, and they basically told her to hit the road because she went back 3 times saying her car was smoking and the car was running rough, and this car was brand new at the time. It was her first oil change. And I don't know why the shop didn't do more, but it kind of blew her off. And when I called them up, they kind of gave me a nasty attitude. But I did my part. I basically drained the oil and took out over 11 liters, 11.6 quarts. Meanwhile, it only needed 8 liters or 8.4 quarts in there. Now, the lady, once I showed her how to get her little like iDrive type of setup to look at her oil, I folded a page in her owner's manual. She did a little more reading and found that too much oil, of course too little oil, can do severe damage. We winded up doing a whole bunch of diagnostics on that. She brought the dude, unfortunately, to court because he wouldn't give her her money back, and she got the money I charged her plus the money he charged her back. We don't need to go there. If you're not sure, and believe me, we have all 4 information systems here: All Data, ProDemand, Identifix, and Motologic, and we get brand new cars in. A lot of times there's not the info in there. So what do? You call the dealer up. You go, hey, Bob in parts, I got this particular vehicle here. What oil does it take? What's the rating? This would be an ACEA rating. And he would tell you maybe it is a 540 or a 040, whatever the case may be. You're going to use that particular rated oil in that vehicle. And how many quarts does it take? What do I need? He's going to tell you. What filter number? Then maybe you want to call your favorite parts store if that's the case, or just buy it off the dealer. But we need to have the right information to fix that vehicle. Now, relative compression, we talked about doing this. Now, this is the eScan, works on any car, whether it's a Chevy, a Hyundai, a Honda, a BMW, or a Mercedes. And basically what you're looking at here is the voltage is going down as we crank it. Let's say we started with a 12.6 volt battery, fully charged battery. It's going down to give us relative compression. Now, it doesn't mean it's telling you it's the actual compression of a motor. It's relative. As long as these are all similar, on most motors, I would say this is accurate roughly on about 80-something% of the motors. If you get DOD, displacement on demand, or MDS, the Chrysler system, basically multi-displacement system, we see it doesn't work on those at all, okay? So you got to know where it works, where it doesn't work, but it's so important that Ford on their IDS, their factory scan tool, puts relative compression in there the same way these guys do it, right from the diagnostic link connector as voltage drops. Toyota Motor Company, another major company, right? They do the same thing in TechStream. So 2 major companies out there because their own people were changing a lot of parts that didn't need to be changed. If you have a mechanical problem, throwing a new mass air fuel sensor, or any other part at the car is not going to help the vehicle run right. Now here is doing relative compression from the driver's seat. Let's blow this up. And I have my Bob there. This is from AES Wave, my friends Carlos and George. And I'm in pin 16 on this old Verus. It was a while back. And pin 4, chassis ground. The vehicle has clear flood. I also have my scan tool hooked up at this particular time here. And all I did was clear flood the vehicle, hold the pedal all the way down, crank it over, and in less than 25 seconds, with my scope coupled to AC voltage, I can tell I don't have a mechanical problem. Why? I got even spacing. All the peaks are roughly the same. Oh, but hold it, G. I see one peak coming up there. It looks like a hair out of place. Don't worry about that. That's what you don't worry about. You worry about the spacing and the height. Does that make sense? So about 80-something% of the cars have clear flood. They have to be under 8,501 pounds. Anything over 8,501, then it is not OBD2 compliant. Now, always look at the label under the car, but many car manufacturers do not use clear flood. Okay, the connectors look the same on all the vehicles, called the DLC, but it may not have clear flood. So please be prepared to do what you need to do. Now, monitors. Monitors are something that are important. Now, in your state, you do have an actual inspection program. When people don't have inspection programs, they go, oh, I don't care about that monitor stuff. Yes, you do. Because you know what monitors will do for you? It'll prevent you from someone coming in on a Friday night when you want to go home and say, you suck. Yes, you suck because you charged me to fix the car that had the light on and now the light's back on. Wow. What do you mean? Well, here's what we do on every vehicle that comes in, because we're in an inspection program here in New York State. We make sure all the monitors are ready. You see like this EVAP monitor? You may have fixed their O2 sensor and the O2 monitor went, but the EVAP didn't run yet. You need to document it. We actually put this into our repair shop program, and basically we could email this. We could actually print it. We print it in full color for the older people. Newer people want to text or emailed. Saves me ink. It's all good for me. But we show them and explain, look, you know, Mrs. Smith, you don't have the EVAP monitor ready. It could become ready and the light may come on. So you may want us to hold on to the car, drive it home, you know, on your dime, or you may want to drive it around yourself and we can come back and check it for you. But we don't want you to get excited if the light comes on. Here's what we fixed. Document everything. Very, very important. Now, some of the other things you need to know, again, this is a part of a big class, but I'm giving you all different pieces here. When you change an oxygen sensor, and let's blow this up, you have to do this on many vehicles, and this is an example. You can see right in all data on a Cadillac, and GM has been doing this for years, heated oxygen sensor learn reset. Have you been doing this? If you don't do it, you could run into a problem. When replacing an O2, perform the following. A code clear with a scan tool, regardless whether or not a DTC is present. A heated resistance learn reset with the scan tool, if your scan tool can do it. Many and most do, by the way. And perform this in the order above so you don't have a problem. It has to have a resistance learn value. If not, water break there. If not, you know what's going to happen? You guessed it. Either the O2 is going to be bad or that engine is not going to run right. So there's where RTFI, read the frickin' information. You don't know everything. I always tell people I got the G and a half an O. I'm never going to get the other half an O and D and be God. Only God knows everything, right? So no matter what instructor tells you he knows everything, or I love when I hire people and they go, I know everything. I go, oh, well, you must be walking on water somewhere. I just don't notice it, right? No one knows everything but God. So we learn something new every single day. Let's look at some scan data here. Here we're on a Jeep. We have Bank 1 Sensor 1, desired. When you see the word desired, you see that right there? Let me go to here. You see that word desired? When you see that, that is telling you the spec. It wants me at 2.51 volts on Bank 1 Sensor 1. Here's my voltage. Bank 1 Sensor 1, O2, I'm actually at 3.3 volts, okay? So desired, now here in the back, we also have desired Bank 2 Sensor 1, Bank 2 Sensor 1 actual. You see where I have these arrows, 2.5, 3.3? Now you go, hold it, Jay. This got to be some crazy sensor. Well, do you realize that the data of that oxygen sensor, when you first put some of them on, you may see 5 volts. They are using a chassis ground to give you that information. It's really a 1 volt scale going from 2 volts to 3 volts or 2.5 volts to 3.5 volts. It's not some crazy setup like the old Renix system of years ago that was a 5 volt sensor that went down, a variable resistor. Here what you're having is something that's different. If you back probe it, and I don't think I have it in this class, no I don't. I show you the same thing on a GM vehicle that actually shows about almost 2 volts if you use chassis ground. If you use signal ground, pin 5, okay, you use signal ground, you're going to see that you would see only a 1 volt scale. Why are they doing that? They're raising the level off ground to prevent interference on that circuit. So some scan data there. And fuel trim. Hey, there's nothing more important than fuel trim, and we love using the eScan, okay? Why? Because I can see right away if I have any issues going on. I got a little something going here, but that is not a bad fuel trim reading if I'm looking at long and short term. In this case, it's only long term. I usually have that on long and short term. The other thing we can do real quick is the VE test. So we can see, it tells you on the bottom, that the math is in yellow, the actual, the calculated is red, and that's because we're a couple of 100 feet above sea level. New York City is about 40 miles north of, we are 40 miles north of New York City, and we put the temperature in, and we go pedal to the metal, and it will give us our actual calculated load. If it didn't reach that, then we know we got that particular problem, right? You can rule things out. Another big thing is, you know, the #1 code in the country is P0420. And when you're looking here, the front O2 is yellow. The rear should be a straight line, either high up, in the middle, or on the bottom. Here you can see it's switched and went from high to low. We don't care. Alongs the rear O2, and you can do this on a regular scan tool. Take your favorite Snap-on or Launcher or Autel or whatever, and actually graph the front and the rear. Do it at idle, because some people, like GM, have an idle catalyst monitor. Sometimes do it, as they recommend here, 18 to 2,000 RPMs, and I also do it at about 25 to 3,000 RPMs. You know why? Because if you look at drive cycles, most manufacturers are going to use one of those three. If you pass idle, you pass 18 to 2,000, you pass about 28 to 3,000, all of it where the rear is not dithering, you're not going to get a 420. If it does dither, dithering meaning going up and down like the front, you're going to have a DTC, and you're going to need to diagnose that. Let's look at mode 6. In this case, you can see we're on the Toyota Tech Stream. Our EVAP is the one with the problem. You got to pass. It's like the Fonz. Hey, it looks good. You got, whoa, no good, right? The no good, we hit the little glass here, we pull it up. Let's take a look at that pull up. And I'm going to have to speed along here, it looks like. Right here, we got a pass, so I'm not going to worry about Vapor 1. This is a canister that has 2 big plastic round things on the back. We got a fail. We got an air side. We got a fuel tank side. The purge is good, so I ain't going to jerk with the purge or the pressure sensor. I'm going to go right after the leak, and the difference is I have a test value of 5.4, and it says a minimum of 5.8 is why I failed. Here, I got a pass, minimum 7.9. I got a test value of 20. So mode 6 can be super helpful. Remember, mode 6 fails a few times, then it jumps into a pending code, fails a pending code 3 times, goes into a regular DTC. Now, people hate gas analyzers, but gas analyzers are great. Here on this Hyundai, we removed the air fuel sensor, left it connected, but we have our back pressure probe in this hole where the air fuel was. Our 5 gas analyzers in here to show you what the suck, squeeze, bang, blow, intake, compression, power, exhaust is doing before the cat. Hydrocarbons, raw fuel, 185. CO, carbon monoxide, the stuff that'll kill you, 0.19. NOx, oxides of nitrogen, 1.27. CO2, combustion efficiency, you know, the evil stuff that actually gives us global warming, 12.69. Oxygen, 19 to 21% of the air we breathe. There's 2.15% left, and lambda should be roughly 1. We got 1.0. Look at after the cat, what a catalytic converter does to clean it up. 0 hydrocarbon, 0.01 CO, 14.89 combustion efficiency, 0.02 because the catalyst is an oxidizing cat. It took the rest of the oxygen left over, just like if you were making a campfire, it was smoldering. If you fan it, what happens? It ignites. Same thing with putting on your torch with the acetylene. Once you add oxygen, we know the flame changes, right? Not all that black stuff going up in the air. And we got a perfect reading of 1 on lambda. Fuel volume is important, not just pressure. So we want at least a half a gallon a minute on most of the vehicles we're working on. A 4-cylinder, non-turbo or supercharged, you can get away with 4/10. But a 4-cylinder turbo or supercharged or 6, 8, and 10-cylinder, you need a minimal of a half a gallon a minute. You could also do current ramping on my Fluke 196C here. We show you the old fuel pump, and each one of these we have 100 millivolts per division. 1 amp, 2 amp, 3 amp, 4 amp, 5 amp. It's about 5.5 amps. The new pump, dark blue, is a 6 amp pump. And if you're more than 1 box difference, like we have here to the highest port there, that's when a pump needs to be replaced. And in this case, we had a drivability issue. All we did is take the relay out, put a jumper wire with a fuse, and go from 30 to 87 to capture that reading. On here, using the AES file, we can take the Fluke 196C, pull up the last reading that we had from the old pump, put the new one right on top of it. Now let's talk about some fuel stuff here as I'm running out of time. You can use these fuel testers. This is the one we used in that video. And this is really tough. You have to get where the pressure is, let's say 38 pounds, hit the button, see where it drops, start the engine up so you don't hydrostatically lock it. Whew, that's a lot of work. That's a lot of work to find out that you may have an actual fuel injector not putting out the same amount. For argument's sake, you may have one spraying too much going down to 5, one going to 28, next one going to 28, and one going to 20. Okay, so you can see if you have a problem. Well, here's an easier way to do it. Use a pressure transducer, connect it just like a fuel pressure gauge. Put it on the rail, and in this example here, using the E-scope and the E-pressure transducer, we can see that we got a problem here. We got a problem here on this cylinder, on that cylinder, and that cylinder, and all I did was hook up my pressure transducer to the fuel rail. It's a lot easier to do and inject the flow test. When you have a problem like here with fuel trim, and we're showing high problem on the high end, this is a little anomaly that did happen on the bottom. It wasn't a vacuum leak, but we had a clogged fuel filter. Once you're done changing the fuel filter, what you need to do is reset the adaptive trim. If you don't reset the adaptive trim, that vehicle or engine may be running bad for quite some time. Now, the next thing here is this was a GM factory scan tool, or not scan tool, a computer tester, excuse me, from 1980 all the way up to 1996. This little box here showed you every power and ground. It also told you if you had how much current per solenoid, and if the little light lit up right here in the right lower corner, that light lit up means you are over current. Now I said, wow, this is a great tool. I would love to have this for every car. Well, they don't make it for every car. Volvo had something similar, but since you're not always working on a GM or a Volvo, and it only can go up to 1996, your best friend, a power probe, can help you. Now, you got to disconnect the wiring harness. Disconnect the wiring harness. And when you do that, like 12 volts coming in somewhere over here, there's ground, and battery power, ignition right there, right over here, is 12 volts going in. But when I disconnect the computer, I no longer take 12 volts to go out, let's say, to some solenoid to power it up. And if it's going out to shift solenoid B, power, I need to put the power probe there. Then I could put the other leg, the ground leg, to the other part of the solenoid where the computer would supply ground. And I could put either my meter in series or use an amp clamp around the wire and actually see what the current draw is. Anything more than 1.2 amps, that's 1200 milliamps, for more than 6 milliseconds will burn a computer circuit out. Not because the G-man says so, okay, but you read documentation here and go to sae.org. You could also buy the Bosch Automotive Handbook, and there's a bunch of information about that. Indexing, super important because they use diodes in a bunch of the stuff. And when they use diodes, if you put power or ground to the wrong side, you're going to have a problem. As you can see here, my student has one injector. He already turned the key or power button off. Then he turns it back on to find out which side is power and ground. Do not disconnect and connect power, okay, with the key on. Yeah, I know you did it a million times, but you don't want to spike anything. And when they put diodes in, so you got Siemens, Sachs, Bosch, and Pierberg, they're all German companies that make components. They make them also for the Asian vehicles and even for Ford Motor Company and a couple of other domestics. So if there's a diode in there and you don't know that and you put power and ground to the wrong side, you're going to have a problem. So it's easier to index. When you take that wire off and now put the power back on, maybe this side's the power side. Maybe that side's the power side. Well, you'll find out which one it is and then go to the component and you can put your power probe with the proper connectors to the right side of that component, power and ground, so you don't burn anything out. Now here we have a Honda, which is pretty common. We're using in-cylinder pressure transducer and we're doing running compression. We're at 70 PSI. We can see our pocket here. Our reading is 3.229. Our exhaust valve, this is exhaust, this is intake. We're definitely too high right here. This is because it needed a valve adjustment. Look at the difference after. And again, before, 3.29, 1.6. All the difference in how this engine was running. This customer became our customer after a shop sold them a whole bunch of parts that didn't fix their problem. Don't forget the basics. Valve adjustment is one of them, especially on a Honda. We're getting close here to the end. We have a 99 Toyota RAV4, and we're using the actual factory scan tool here, and we're doing a health check. We come up with two DTCs, a 171 and a P1130. Now, that being said, we find out it's an air fuel sensor, and another shop already replaced a whole bunch of parts. We look at this thing, we're going to go into freeze frame. Look at this, 44% long-term fuel trim. 44%, almost on track. 44%. Now, here's what you got to know. You have to look at the rear O2 sensor. So you see the front, if you know Toyota should be 3.3 volts. Well, roughly, we are at 3.27. We had 0 in the back when we started. We put a new O2 in. We now have 0.085. Always make sure when you're looking at a rear O2 sensor, many companies look at the rear O2 for fuel control. Always do brum, 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 and see if the rear moves. If it don't move, then you got a problem and you're probably in fuel control. That being said, in a New York minute, right on time there, so Brenda doesn't get mad, okay? Don't forget to sign up for PAVE. You can have my annoying face there, as well as many great instructors, and it helps out a whole bunch of the different organizations that help take care of you all year long, like ASA Washington, right? So there'll be great training, you get your money's worth, and watch this, you can go back and get nauseated, watch me or some other guy over and over for 1 month. Is that correct, right? 1 month. We'll give our TST a big, our TST big event. We are March 19, 2022. According to New York State right now, we could have a lot of people, not our maximum amount. Fortunately, you got to wear a mask, but we will have some great instructors, great giveaways, and we do this. This is our 19th or 20th year. We hope to see you out there. And from myself, G. Trulia here in New York, I want to thank you for your time, and I'm here if you've got any questions. Did it. So if you have questions, you could open them up for questions.
Gee, thank you very much. That was a fantastic presentation. I put out there in the chat they can unmute and ask questions.
Yeah, please ask questions. And if you want to keep your face off, you know what I usually say, I've been talking to this camera way too much. You can see me, but I can't see you. But maybe if your picture's on, then I can see you. You can leave it off. There's no such thing as a stupid question. So I'll try to answer your question if you have any. How many of you out there are using pressure transducers? I know that's a biggie that you probably had maybe my buddy Bernie Thompson on or others that have done some stuff with pressure transducers. Comes in real handy. We use them here in the shop quite a bit. We have another Dodge Ram out there with a a bad motor and we can't get parts, which is a real nightmare. But the pressure transducer confirmed a problem. So I don't know if there's anything there.
How many milliamps there in the old flux capacitor?
How many milliamps in
The flux capacitor.
flux capacitor?
I'm just joshing. Hey, this is Carl Kikui. I just wanted to say that your knowledge is amazing. Clearly you've done this stuff backwards and forwards, and so thank you so much for the presentation today. It was really great.
Oh, well, thank you. I really appreciate that. You're making me blush. No, but I do appreciate that when people, you know, actually get something out of it or like it. You got to make it a little bit amusing. I've done a lot of these and been doing them for years. My whole objective is trying to help technicians. Not only I donate my time to our non-for-profit TST, and of course with my company I do it for money because I got to pay bills. And for ASA, because that lovely Brenda, I did it for free. How about that? And happy to do so. Thank you.
Appreciate it.
Thank you.
Great presentation. So thank you everyone for joining us.
Thank you again. Oh, happy Veterans Day. Thank you all who served, okay? And happy Thanksgiving in advance. Don't forget, get that turkey while you can. It may be on a barge somewhere. Okay, I'm done.